We've already taken a look at how to find reference angles in radians when our denominator is one of the special denominators, whether that's a 3, a 4, or we've also seen that 6 is a special denominator. When we don't have that case, for example down here, we'll need to do something a little bit different. It's not as easy as just saying the reference angle is 9 over pi. However, it's not too complicated. So here's what I'm going to do. Basically what we're trying to do is, remember, get to the x-axis. Your reference angle is always the angle formed between the x-axis and wherever our angle ends up. So 7 pi over 9 is going to be somewhere over here in quadrant 2. I know that because I remember that this over here is 1 pi, and if I make a full revolution around the circle, it's 2 pi. So really all I'm trying to do is get to 1 pi or 2 pi, or you can kind of think of these as what do you need to add to the fraction to sort of complete the fraction or make it a full whole number. So this is going to be my reference angle, that piece that's missing right there. Well, I already know that to get here, it took 7 ninths to get there. If I want to complete that fraction or get to one full integer value, 1 pi, I know that I need to add on 2 pi to that, because 7 pi over 9 plus 2 pi over 9 will get me to that 1 pi, or that full sort of half revolution to get to that full number. Okay, so that's what I mean. We're sort of completing the fraction. I have a 7 out of 9, so I'm missing 2 pieces out of that, is kind of how I like to think of these. All right, so let's try a couple more to make sure we have that idea down. Next up, I have negative 4 pi over 7. So 7 is not one of my special angles. That negative sign just tells me to rotate clockwise instead of counterclockwise. So again, I know I'm going to end up somewhere over here in quadrant 3. I'm a little bit past that halfway point. Remember, this would be 0.5 pi. Or really negative 0.5 pi in this case. So again, I want to think about what do I need to do to complete that fraction, to get to the x-axis, to get to either 1 pi or 2 pi. So I again want to get to 1 pi. The negative doesn't really matter anymore, because all I need to know is my reference angle is always going to be something positive. Well, if I've done 4/7 to get here, that must mean there's another 3/7 to get to the x-axis. So my reference angle this time is going to be 3 pi over 7 for this angle right here. Not negative. My reference angle is always something positive. And again, think of it as completing the fraction. I have 4 out of 7 pieces, so I would need 3 out of 7 pieces to make that full fraction. Okay, and then one more we'll take a look at, 9 pi over 5. This is almost a full revolution around the circle, because it's almost equal to 2 pi. If you divide that out and get a decimal, you'll see that it's almost 2 pi, or 2, if you divide this out without the pi in it. So this is where 2 pi would be. So again, I want to get to the x-axis the fastest way possible. This time, I want to try to get to 2 pi. 1 pi is way over here. So right now, I have 9 pi over 5. I want to end up at a full 2, a full integer value. So what I need to add on to this is just 1 pi over 5 as my reference angle. Because if we took 9 pi over 5, and added 1 pi over 5 to that, I would end up with 10 pi over 5, which would of course just simplify down to 2. So again, you're kind of thinking of these as completing the fraction, whether you're trying to get to 1 pi or whether you're trying to get to 2 pi, but that's how we'll find the reference angle when we don't have a special denominator.